So now we're going to talk about determining similarity, like proving similarity, but we're not going to actually do proofs. So I know some of you had a little bit of a heart attack there. You don't really need to do proofs necessarily, but we're just going to talk about whether or not two figures are similar. So there's only 3 criteria for similarity, criteria for two figures to be similar. So you had 5 for congruence, but there's only actually 3. So first one is angle-angle similarity. It just says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So, and then that also follows with angle. So it says if angle P is congruent to angle T, and this shouldn't be, angle Q is congruent to angle S, then triangle PQR must be similar to triangle TSU. Okay, so that just says if 2 angles of one are congruent to 2 angles of another, they're similar. This one says there is side-side similarity, but it's not that they're congruent. If 3 sides of one triangle are proportionate have this, make the same fraction to 3 sides of another triangle, then the triangles are similar. Okay, and we did that with the last unit. So this just says if A over AX is equal to B over BX, which is equal to C over CX, which it is, because they're all just, it's the same thing except with X, then triangle PQR must be similar to triangle TSU. The last way to prove similarity is actually side angle side with an included angle, so no swearing in this one either. So if the measure of 2 sides of one triangle are proportionate to the measures of 2 sides of another triangle, and the included has to be included. Angle of one is congruent to the included angle of the other, then the triangles are similar. Okay, so this one says if angle Q is congruent to angle, I did not mean to. That is not right. Sorry, I wrote this backwards. If A over AX is equal to C over CX, and angle Q is congruent to angle S, then triangle PQR must be similar to triangle TSU. Okay, so we're just going to use those 3 things. This is just a little bit more work than it was with congruence because you have to check the proportions. So what are the 3 criteria for similarity? We have angle, angle. It's not angle, angle, angle. It's just angle, angle. Okay, even though the third angle is going to be congruent. Angle, angle. We have side, 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 and we have side, angle, side. Okay, so let's look at these. And if you guys recall from the previous unit, okay, those angles are going to be congruent. These angles are congruent. So I'm going to say yes because 2 angles of one are congruent to 2 angles of the other. And that's the first thing that I check. The next one, okay, I only see 1 angle congruent and I only have 2 sides. It's the included angle. So what we have to look at is, okay, large side over large side is 8 over 14.4 equal to 7 over 12.6. And you can use decimals to figure this out. So I can do 8 divided by 14.4 if you want. So this is going to be 0.5 repeating. And then 7 divided by 12.6 is also 0.5 repeating. You can also cross multiply. So you can do 8 times 12.6, which is 100.8. And then 7 times 14.4, that is also 100.8. So yes, the sides are proportionate. So yes, and that's going to be by side, angle, side. Next one, okay, so the problem with this one is we have one angle and one angle, but we don't have that third angle. So I'm just going to do 180 minus 51 minus 62. And I have 67 degrees. Just knowing that, I know this is 67 and this one is 67. So this is going to be yes by angle, angle. So sometimes you're going to have to solve for an angle. Okay, this one's a little bit tricky, but kind of interesting anyway. So I know that this angle is congruent in both of these triangles. Actually, this one is very weird because it's by reflexive property. I also know, because these lines are parallel, that this angle is congruent to this angle. And so this is actually going to be, sorry about that, this is going to be yes by angle, angle. This next one, this is going to be, well, I only have two things. This is going to be no, this is not, and so we're not going to have criteria, but I'm just going to remind you, not enough info. Okay, and my very last one, I'm looking at this, I have no angles, all I have are sides, so now I have to figure out if the ratio of the sides are proportionate. So I do my largest side, 9, over my largest side of my other one, 10.8. Is that equal to 8, which is my medium side, over my medium side, my bigger triangle, which should be equal to 5 over my smallest side, which is 6. And so I can use division. I can do 9 divided by 10.8, and this is going to be 0.83 repeating. 8 divided by 9.6 is also 0.83 repeating, and 5 divided by 6 is also 0.83 repeating. So this is going to be yes, and this is going to be side, 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 and that's because the sides are proportionate. Okay, last one, I just want to do a couple of problems where we have to write the similarity statement. This one we know is similar by angle, angle, again, because it's parallel, these two sides, and by reflexive property. So I am going back to it. Okay, so my similarity statement, I can say, I'm going to say triangle ABC. Then I look at my corresponding angles. This angle here corresponded to this angle here, so it's going to be AEF. So just be careful with your similarity statement. This last one, let's just see, we have an angle, and then we have our sides. Is 8 over 12 equal to 7 over 12? This is no. Okay, the sides are not proportionate. Okay, and so that's what